Okay, time is 12:30, so let's get started here. Welcome, everyone. This is Stat 494 and Stat 873, Apply Multivariate Statistical Analysis, or more shortly, just call it Multivariate. My name is Chris Builder. I'll be your instructor for the course. Now, the last time I checked the roster for this course was early this morning. I think it's important for you to understand what students are in this course. So for Stat 873, we have 11 students, and they are graduate students, because it's an 800 level course. These are not statistics majors, though, at the graduate level. Instead, these are master's and PhD students from a wide variety of disciplines, such as agronomy, engineering, food science, various biological majors as well. Now, we also have 17 students who are signed up for 494, which, since it's a 400 level course, means it's undergraduate too. And the students who are signed up at the 494 level are primarily, not always, but primarily statistics majors or statistics minors. And so you can see that we have a wide variety of backgrounds coming into this course, which to some respect makes it a little challenging to teach, but also fun to teach. That's one reason why I got into being a professor. But I think we need to go a little bit further in terms of these backgrounds. So some students have had a mathematical statistics course, especially the undergraduates. And what does that mean? It's a course like Stat 462, 463, 301, 302 sequence. Some graduate students have also had a Stat 880 course, which is very similar to 462, 463. And what a mathematical statistics course means is that you've had an experience where you've done some mathematical proofs relative to statistics. Or you've been able to, let's say, show what a maximum likelihood estimator is for a particular situation. Some other students in this course have never ever seen a maximum likelihood estimator before, much less try to derive one. Okay, so you can see some wide backgrounds in terms of the theory behind the statistics. Also in this course, we will be using a lot of matrix algebra. Some students have had it, some students have not. And we will be using R extensively in this course. Some students have lots of experience with R, some have not. And I guess just to sum it up, in terms of the backgrounds for this course, there are some students who probably have had about 10 stat courses at least before coming into this one. Others, this might be their third one ever. And so with my teaching, I'm going to try to take into account the best that I can these diverse backgrounds that we have. So that means, for example, we will start off with an introduction to R, despite I know many of you don't have that experience. Have that experience. There's probably some of you who have not. Also, we will start off with an introduction to matrix algebra. Again, I expect a lot of you have had that experience before, but there will be some that have not. Once we get into about the 4th, 5th week of the course, pretty much, generally speaking, depending upon your background, most of the stuff will be new. But at least early on, for some of you, the stuff will be review. Be patient. If it isn't review, please take advantage of this opportunity to learn this stuff and ask questions if you have it. Okay. So let's take a look at the syllabus for the course. So all of you should have received a message from me via Canvas. And I think I posted it on Saturday regarding that. If you want to have a paper copy of the syllabus or download a copy of the syllabus, go to my corresponding course website. If by chance you did not receive that email, I will show you later on how to actually obtain this syllabus. As I was preparing for class here, I ended up typing a few things in red here. Most of this is just reminders for me to mention it during our class. You're welcome to write it down or type it on your PDF. It doesn't matter. It is mainly there for me to remember. Okay, so again, my name is Chris Builder. Please call me Chris. Don't call me Dr. Builder. Please call me Chris. I just prefer to go by first names. My office is in Harton Hall, where we are at 342C. Let me just show you where that is if you're not familiar with the building. Let's see here. So here's a map here's Holdridge Street. You follow where my mouse is. Here is 33rd Street. My office is in the far northeast corner of the building, in the north wing. It's kind of tucked away, a little bit hard to find, but it's not too bad. Okay. To give you a little background about myself, I'm a native Nebraskan. I grew up in Omaha. I went to Millard South High School, so I grew up in the Millard area. And I got my undergraduate degree in mathematics from UNO. And at the time when I graduated, there was no statistics program in the state of Nebraska. So I had to go out of state for statistics master's and PhD, and I ended up going to Kansas State. My first job out of grad school was I was a professor at Oklahoma State University in the Department of Statistics. And then in 2003, a long time ago, finally UNL decided to form their own Department of Statistics, and I was essentially the first hire for the new department that was formed, although there were statisticians in other parts of the campus that came together to also form the department. I already told you where my office was. For office hours, Tuesdays and Thursdays after this class, if that time doesn't work, please feel free to make an appointment with me. You can email me at builder@unl.edu. Please use that email address rather than sending me a message through Canvas. I just prefer to get it through email. And as you will see shortly, I do have a course website set up that's outside of Canvas at my web portal. You could say chrisbuilder.com, but we will have a few things on Canvas. Now, one thing that you probably noticed and maybe you were happy about was that there was no required book for the course. Part of the reason is this is actually my 10th time teaching this course. I've taught it now on and off for about 20 years. I don't teach it exactly the same as I did 20 years ago, but I have a lot of experience with teaching this, so I have my own set of notes that I developed over the years to teach the course. Someday, maybe I'll write up a book, just not tomorrow. But I do understand that students often would like to have an additional resource to use if needed for a different perspective on some stuff. And so here are 4 different books that can be helpful to you. The first one and the last one I like to especially point out to you is because they are published by Springer. And in case if you don't know yet, at the UNL library, you can download many, many Springer textbooks. And so you can actually obtain these textbooks for free from our library. Another book to point out is this Johnson & Wishern. This is kind of a standard for these courses across the country. They're in probably about the 6th or 7th edition right now. It's definitely not my favorite textbook out there. They do go into some more mathematical detail than what we will in this course. So if you are really into the math side of multivariate, you can take a look at some of the stuff that they have in that book there. In terms of the prerequisites, first let's talk about for Stat 873 students. This is defined in the catalog. Stat 801, Statistical Methods and Research. Basically what that means is that you need to have an introductory stat course that talks about probability distributions, intro to hypothesis tests, intro to confidence intervals, simple linear regression, and various experimental designs such as complete randomized designs, randomized complete block designs. That's what you would get out of 801. And you would also get exposure to a statistical software package. When I teach it, I use R, but other professors sometimes use different packages. But what's also listed as being recommended or strongly recommended is a course on regression modeling, such as our Stat 870. So this is a full semester of understanding regression models, simple linear regression, multiple linear regression, various other extensions to regression, and also more exposure to a statistical software package, but also very importantly, matrix algebra. So everything is done in terms of using matrices to look at regression analysis. Again, we will use a lot of matrix algebra in this class, so that's why that's especially important. Now, what about for Stat 494? Well, Stat 494 is actually a topics course, so there's not really listed prerequisites associated with it because it could be a variety of different topics. So what should the prerequisites be? Well, very comparable ones to Stat 873. And so what that would mean is something similar to stat methods and research, which would be something like the equivalent to Stat 218, 318 here. Introductory statistics courses that go up to talking about ANOVA, the randomized complete block designs, the completely randomized designs. And experience with a statistical software package, which involves programming. Also, relative to the strongly recommended, have a regression course. This would be like Stat 450. Probably Stat 301 here will give you enough background, but you need to be comfortable with stating a regression model, finding parameter estimates, doing inference with regression models, model selection, stuff like that. And also then have experience with matrix algebra. Now, the matrix algebra in the regression part is part of strongly recommended. So, you're not required to have that. And so that's why we spend a little bit of time at the very beginning of the course giving a quick introduction to what R is, a quick introduction to what matrix algebra is to help get you up to speed if needed. Any questions about those prerequisites? Okay. So grades in this class. So we'll have 3 regular tests where you'll notice that first test is only 5% of your grade. This first test, and we'll talk more about it shortly, basically is over this introductory material, such as an introduction to R, matrix algebra, stuff like that. And so I purposely then also give this test early in the semester. So in about 4 weeks, we will have this test. So this will help you determine, yes, you're set up for success in this course, or maybe no. And at that time, then we can make a determination of what we can do to help you. But I'd like to do this early in the semester so that you have a good understanding of where you stand then and if changes need to be made. And it's only worth 5% of your grade so that if you don't do well, it's not going to kill your grade. Then we have two regular tests during the semester, which are 20% of your grade. We will have a comprehensive final that's worth 25%. Now, that test 1 through test 3, what I'm hoping to do is have these computer-based. Typically, what I've done in this class, the last few times I've taught it, is that students they come to class at the regular time and they actually take the tests on a computer that's in the classroom or their laptop. But it's still meant to be closed book, closed note. But you will have access to some of my, you'll see I have lots of R programs available to you. You'll have access to R help. You'll have access to a few other things. That's why I envision that's what the test will look like as we go along through the semester. I'll make a final determination. And then lastly, for this grade, there's going to be about 3 projects during the semester, which will be focused on data analysis. Also, there will be some quizzes, mostly during the beginning of the semester. And to try to put those all together into 30% of your grade, basically what I do is I take the total number of points earned in that part, in terms of projects and quizzes, total number of points earned, divided by total number of points possible. So, for example, if you had, let's just say that there was 200 points possible and you got 190. So that means you got a 95% for that portion of your grade. And when I calculate final grades in the end, I simply look at your test 1 score. Let's say it's 100%. Test 2 is 90. Test 3 is 80. Sorry to go in a decreasing value there. Let's do 100% for our final exam. And what I do is I take 100 times 5% plus 90 times 20% plus 80 times 20% and keep on going. That's how I find your overall percentage grade. For 873 students, we have a standard grading scale associated with it for A's through F's. For 494, since these are undergraduates, there's a little bit of more leeway in terms of the grade categories there. I do assign plus and minus letter grades, and they are 2.5% from those cutoff points that you see there. Most of the stuff that we will do in terms of what you turn in will be done electronically. Rarely will you ever give me anything that's paper-based. And especially for some of these projects, which can be long, I want you to turn them in to me electronically. We'll probably do email. And do note that no late projects or quizzes are accepted. Please make sure you abide by the due date. In terms of these projects, after you're done here at UNL and you've got a job in the real world, typically you're working with a team of people. And so because of that, I like to make the projects group work. For this semester, we're going to have a maximum size of 4 for the groups. We won't need to start doing projects until mid to late September, but you can still start thinking about now perhaps who you want to work with in your group. And I understand there are probably some students in here that don't know any of the other students. And so I will have a mechanism in place to help form a group if needed for you. And at least for project number 1, I do want you to work in a group. Of course, the one downside of group work is that you have, let's say, 4 people in your group. 1 person does all the work, 3 people don't do any of the work. Don't do that. That's not how group work is meant to be. You're supposed to, one benefit from group work is learning from your other group members. And so if I do see that it's just 1 student or just 2 students or whatever that is doing all the work, but the other one's not, I will lower student grades. I have done that before. As I've been getting into or been talking about, we will be using extensively in this class the statistical software package called R. This is the language of statistics, so that's why we use it. We will have a little bit of an introduction to R later, but for those of you who do not know, R is available for free at this web address there. That's the Windows version. There's also versions for other operating systems too. During class, I will be recording what's going on in the class. So you can kind of see I have a simple webcam set up in front of me. And so I will record all our courses, except for obviously tests. And I will post the recording to my website. I'll show you where to obtain that later. That recording might not be there till, it should be there by 5 p.m., but it might not be there until later in the evening sometimes if I have, let's say, like meetings after class or something like that. Use these recordings as a way to review what's done in class if needed. Use these recordings if by chance you weren't able to attend because you're sick or your car breaks down or something like that. Don't use these recordings as a way to skip class. The final exam is scheduled for 7:30 a.m. on the last day of finals week. Don't blame me. but I will be giving the exam that time. Please don't ask me to give it to you earlier. So what are my expectations of students? Well, I have an extensive set of course notes set up. Understand all the material that's in there, unless I by chance say you don't have to worry about that or worry about something. Okay? I wouldn't take the time to write it up if I didn't think it was important. We will do a lot of R programming in this class, so it's important for you to understand the corresponding code and the calculations that are created with this code. A great place to start learning in this class, let's say after you get done with a class period, is to go home or go to your office and start reproducing the examples that I've done in the notes. If it's code, go through it line by line, for example. Review the class recordings as needed. I do have a lot of practice problems available to you that are not graded at all, but just to give you extra practice. I'll show you where to obtain those shortly. These practice problems, some have solutions, some do not. And of course, please, please, please ask questions when something is not clear. And I was trying to emphasize that despite my circle disappearing. If for some reason classes are canceled at UNL, I will post to the discussion board on Canvas what we're going to do that day. Maybe we'll meet just on Zoom, for example. And lastly, there's additional information that's available at the Academic Affairs website for UNL on stuff like emergency procedures, academic integrity, and stuff like that. Please go there and take a look at them. Okay. Any questions about the syllabus? Next, let's take a look at my course website. So if you go to chrismiller.com, you simply go here. So I have my teaching stuff, I have my research stuff, I have some other stuff listed there as well. And if you click on Stat 494, 873, that will take you to the course website. Towards the top, you're going to see a simple menu bar to get you to navigate to certain areas of the website. And so if we simply click on Canvas here, we can see what do we use Canvas for in this class. The discussion board that's in it, to take online quizzes, and also I will post grades there as well. So let's go ahead and go over to Canvas. So this is what it will look like when you go to our website. Do note that whenever you have a course that is cross-listed, undergraduate, graduate, Canvas puts everyone into, let's say, the undergraduate version of the course, at least in terms of the title, what you see here. So it is actually 873, despite it saying 494. And so let's take a look at discussions. So most of you probably have experience already with a discussion board in Canvas. The main thing for me to talk about here is what do I use a discussion board in this class? And so that's the purpose of this welcome message. Simply, I use it as a way for if you have a question about some material that was discussed in class, or if you have a question about a practice problem, or if you have a question about something that's on a project, post it here. Because if you have that question, probably somebody else in the class also has that question. That way, when I respond to your question, everyone can learn from it, rather than me simply replying to your direct email. Now, if you do have a question about your specific grade, or you want to tell me that you're sick, you're not going to be able to come to class, or something that's just for you, you can go ahead and email me that. But if it's something that basically other people can benefit from seeing my answer to, please post it to the discussion board. when I've taught this course in the class, we might have up to about 80 postings in a semester. Half from me, half from students. To put in perspective how much this can be used. Also, you can use this discussion board just simply to talk to everyone else in the class. Like for example, does anyone need a group member? Or did anyone get the answer to a particular practice problem or something like that? Okay? So make sure with your settings in Canvas that you're actually subscribed to discussion boards, because you will get an automatic email sent to you that there's a new posting. And it's very important that you do have that done, because if I will also post other stuff here that it's important announcements, such as maybe I'm sick for the day and I can't teach. I will post a message to the discussion board to let you know, don't come to the class. Now, in terms of the quizzes then, so what you see here so far, about 6 different quizzes that I've posted. These are meant to be typically low stakes quizzes. They're worth typically like 5 points each. And this will be put into that projects and quizzes part of your grade. It's just meant to give you a little bit more practice on some of this stuff. And also for me to find out more information about you, which is the purpose of what I call the week number 1 quiz. Note the due date, tomorrow at 5 p.m. I know that's a quick turnaround, but this is going to be an easy quiz, and it's just going to give me information about you. The sooner I know that information, the sooner I can make changes to how I plan on teaching if necessary. Okay? So let's take a look at the week number 1 quiz. Okay, so question 1, what is your name? 2, give me your email address that you want me to use for communication. 3, tell me what your major is, what your degree that you're pursuing is. So like statistics, bachelor's. Okay, or agronomy, PhD. Actually list out all the statistics courses that you've taken before. I do want to see them all. Tell me what the highest math course that you've ever taken is. Is it algebra? Is it calculus? Is it real analysis 2? Tell me what I want to know about your math background. Question 6, simple. Do you have access to a laptop that can be brought to class? Most of you already have a laptop here, so I know what your answer will be, but tell me yes or no. Then number 7 gets into more of this diverse background that we have for students coming into this course. 7, tell me, do you have experience with R? If so, briefly describe your experience. It could be classes, it could be maybe your research that you're working on. Tell me how you have experience with R. 8, have you actually taken a matrix algebra course, like UNL Math 314? If not, do you have other matrix algebra experience? So especially for graduate students, they will often not have a course like Math 314, but they will have experience with matrix algebra through their research that they're doing, or maybe with some other graduate level courses that they're taking. Next question, have you taken a regression course like UNL Stat 450 or Stat 870, or like the 301, 302 sequence, which would have some regression in it? And lastly, tell me where you're from. Okay? So, of course, whenever you take one of these quizzes, if you haven't before, it's very important you select Submit Quiz on a Canvas quiz. Otherwise, I don't know that you have it done. Please get this done by 5 p.m. tomorrow. Okay. Let's see here. So back to my regular old website. I have a graded web page. This is just stuff that we're going to have graded during the semester that I will post there, such as projects. So often what I will say, hey, project number 1's available. Maybe I put this on discussion board. Project number 1 is available. Please have it downloaded to your computer or have a printed off copy. Bring it to class so that we can discuss it. Tests during the semester, I can post there as well. I typically post answer keys with the test too after everyone's taken the test. Something that you will find useful even now, even before we do a project or a test. I have this formulas function sheet, which I originally put this together to help students take a test, since it was closed book, closed note. But you can use this throughout the semester. And what this gives you is a list of important equations that we're going to be looking at. So you can see for matrix algebra, how to multiply two matrices together. And then if we come down here, you see every R function that we're going to be using in this course, along with a description of it. So this could be a nice little quick reference for the stuff that we're going to be doing. And as you can see, as I page down, let's see now. So that's on page 5, all the way down to page 9. So there's a lot of stuff that we're going to be doing in R. Okay, I'm going to jump over to section materials. So notice day number 1, that means today. Here's where you can download the syllabus if you missed my Canvas message. Now, I've broken up this course into sections. And on this webpage, I give the various materials associated with those sections as well. And so section 1 is background material. How to use R, matrix algebra. I've said that a number of times already. Then we start getting into what is multivariate data. So multivariate data, multi means multiple, variate means variable. This course deals with how to analyze multiple variables at the same time. And so we do an introduction to the type of data that we're going to see. So for example, maybe we might have 10, 20 variables associated with each experimental unit that we have an observation on. We'll talk about distributions involved, probability distributions involved with multivariate data. So all of you have seen a regular old normal distribution. Well, what happens if you have multiple variables? Well, now you have what's called a multivariate normal distribution that you can work with, for example. And if we take a look at the sub-bullets associated with this, you can see a general way that I structure these materials. So with each of my, I guess, subsections, I have a set of course notes. And so they're simply Word files, and this is what they look like. I use a size 20 font when I type up these notes because that way I know for sure wherever classroom I'm in, the font's going to be big enough that everyone's going to be able to see it. If you're still someone who, let's say, prints off notes, I recommend that you print them off basically 4 pages per sheet of paper. That's what I have found to be the optimal way to view it. And so I have these notes here. I also have corresponding R programs. So cited in these notes will be a program called serial.r, where we're going to be looking at some multivariate data corresponding to nutritional information for cereals that you will get at a grocery store. I also have a corresponding data set that we're going to look at called serial.csv. I primarily just work with comma delimited files, so that's what .csv means, comma separated values. And then also I have a set of practice problems for you to work on as well. Again, partial answers are associated with these practice problems. There's nothing there that's graded, nothing that you need to turn in. So section 1's background material. Section 2 is summarizing data, where now we have multivariate data. How do we summarizing. Well, a good place to start is with a graph. And so I have a whole section on graphics, where we start with one of the most basic graphs that you've ever seen before, a scatter plot. Of course, a scatter plot's for 2 variables. But what if I have 3, 4, 5, 6? How can I get those other variables shown on that scatter plot? Well, we'll talk about that. But there are limitations. So what we'll have to do is more sophisticated graphical methods. So we'll talk about what are called parallel coordinates plots. We'll talk about trellis plots. We'll talk about star plots as a way to represent multivariate data. So typically in an analysis for multivariate data, first thing that we do is try to plot the data. Try to better understand it. Try to look for maybe some general trends that you might be able to see in the data. Then we can go start using some other statistical methods. 2 of these are very similar to one another: principal component analysis and factor analysis. So there's principal component analysis. And what those methods do is say, okay, you have all these variables, let's say 10 variables. Could we somehow look for some kind of transformation of that data to a more manageable number of variables to look at and analyze those instead? So instead of 10 variables, maybe we could just work with 2 variables that are transformations of these 10. And if we only have 2 variables, well, we could use a simple scatter plot, for example, of just those 2 variables. And so it makes it more easier to make sense of the multivariate data. Then we talk about cluster analysis, which changes things a little bit. It says, okay, we have all these observations where we have multiple variables associated with each of these observations. Maybe we could try to, let's say, find some observations that are similar to one another and categorize them. That's what we do with cluster analysis. And we'll look at a variety of different ways to do cluster analysis. And our last main section is simply prediction. So to give you an example where this could be used, one project that I worked on a number of years ago was I was working with some engineers, and they were looking for a way to determine what's inside an unexploded artillery shell on a battlefield. So not every shell will explode. You can just imagine one on the ground. You probably don't want to touch it, so you don't want it to explode. So they were looking for ways to bounce some sound waves off this artillery shell, and based upon multiple variable measurements that they got back, determine if it was, let's say, mustard gas filled. Was it some kind of explosive material in it? Maybe it was empty. And so we want to predict what's inside of it. Another quick example is, let's say, a clinical trial for a new pharmaceutical drug. Based upon multiple measurements that you're taking on these people, you want to determine, is that person going to survive or are they going to die? And so we want to predict these classifications. Some people even say we want to predict what population is that person or that let's say, the observation from, and then apply it to new observations in the end, or new data in the end. That's what we do with prediction. You could do a whole class on prediction. And if you've had any kind of statistical learning course, you're going to see some overlap with that. In fact, I would say this is actually the original statistical learning course, Multivariate. And so we're going to begin with something called discriminant analysis, which has a underlying probability distribution assumption for your data, what's called a multivariate normal. Then we will look at something called nearest neighbor classification, which basically takes away those assumptions. Sometimes nearest neighbor classification will work better than discriminant analysis, and vice versa. There's not necessarily one way that's always the best. That's why we learn about multiple ways. We'll also talk about how we can use logistic regression in this setting. logistic regression is like rigor old regression if you haven't seen it, except for your response variable has just two categories to it. Multinomial regression, two or more, well, let's say three or more. And then depending upon if we have the time, I don't have the notes set up yet for this, we'll talk about something called random forest as well. And then lastly, there is a small section for which I usually only discuss at the very end of the course. 20 years ago when I first started teaching this course, these classical methods, I guess people wouldn't call them classical then, but I call them that now. When I would teach this course 20 years ago, we would spend about a fourth to a third of the course talking about these methods. I think there's more important things to do, but there's still some interesting things, so I leave that to the end of the semester. One thing that we would do there, for example, is the extension of a regular old t-test, where if, let's say, your first stat course, you learn to do a t-test for, let's say, mu1, is mu1 equal to mu2? Population mean for population 1 is equal to the population mean for population 2. What if instead of just mu1 and mu2, you could think of mu as being, if you have a matrix algebra course before, a vector of means. You want to check, is this vector of means equal to that vector of means? If you're not familiar with what I mean by vectors, you can think of it as, let's say, maybe you have 5 means. Are they equal to these 5 means? Okay? So that's the materials that we have available in this course. This is also gives you a little bit of introduction to the topics in this course. And then lastly here, let's take a look at the schedule for the semester. So for today, we did the syllabus. We're just finishing up the website right now. That week number 1 quiz is due on Wednesday at 5 p.m. After class, I will post the video from my recording here to right where you see video, and you'll be able to click on it. And then lastly, we will start doing a little bit of an R introduction. Then on Thursday, we will continue with an R introduction. But before that, before Thursday, I want you to go to the section materials where you see my notes for the R introduction and go through these 4 documents that I have for my R introduction. Now, rather than us going through those notes in class, again, I understand, I would expect most of you do have a background in R. Even if you do, take a quick look through them. If you don't have a background in R coming into this, or you're not comfortable with R, take a long look through these notes. These are notes that I use in any class where I cannot assume that there is an R prerequisite. And so this is something I will use in other classes too. And because of that, I actually have video recordings of me teaching from those corresponding notes, and you can watch the videos. And even if you do have a very strong background in R, please take a look at that example there, set of notes. I do a simple linear regression example involving high school and college GPA. Make sure you're familiar with that data set because we will use that data set in the matrix algebra section as well. So between now and our next class period, take a look through these notes. How much you get into those notes depends upon what your background is coming into this class. Then on Thursday, we will continue talking about our introduction, where I will only have about maybe 15 minutes of prepared material. And then the rest of the class period is meant for questions and answers. So if you are not comfortable with R, this is a great time to ask questions. And in-person attendance is optional. So I know, especially for the stat majors here, I expect a lot of you to already have a lot of experience with R. If you don't want to come to class, that's okay, but at least take a look at the materials that I have, at least quickly. What's happened in the past with this second class in the semester, when I've set up my multivariate course like this, it often will become more of an individual help session for those who do need the help on R. And so that's why I don't prepare much of anything for that class. Then next Tuesday, we will do an introduction to matrix algebra. As a way to motivate this, we will take a look at a simple linear regression example involving this high school and college GPA data set that I just talked about, where we will explore the very basic idea of setting up a matrix, how to do multiplication, how to do inverses of matrices and stuff like that. There will be a quiz, which I simply call week number 2 quiz, due on that Wednesday at 5 p.m. If I remember right, I think that quiz might only be over Introduction to R. You will be able to access the quiz now if you want to take a look at it. I think if I remember right, it's just Introduction to R. The matrix algebra stuff, then I wait until the week number 3 quiz. So we do matrix algebra, then we get into this data distributions and correlation section, and then eventually we have a test on September 18th. So you can take a look at some of the other aspects, I guess, of the schedule on your own. Do note that these test dates, unless school's canceled for some reason, these are set in stone. So please be here on that day. Okay. So I think that's all I have with respect to the website. Any questions? Okay. So at the very beginning of every class, I'll have a document like this up, which just kind of explains what we're going to do, or I guess you could say outlines it. And at the very bottom, we have a reminder of what's next, what's going on in our class. And so, hold on here. There we go. So we've done this so far. Let's start a little bit of introduction to R. What I'm going to say here is actually also in my video. It corresponds to the notes that we have, that I have set up. Okay. Now, give you my background in R. Let's see. R was created February 29th of 2000. I first used R that fall. It was a very revolutionary thing. I know it's a long time ago, but it was a very revolutionary thing back then because this was the first fully functional statistical software package that was free. An amazing concept back then. Now, R itself was actually very, very similar to another software package. Just out of curiosity, for those of you who had a background in R, do any of you know what that software package was? Does anyone go into that much of a history of it? It has a name similar to R. Very close in the alphabet to the letter R. S, yes. So there was something called S that was created by what was then called AT&T Bell Labs in the 1970s as the first statistics programming language. S for statistics. And then in the 1980s, a company bought the exclusive rights to S. S was free. But they bought the exclusive rights to S and they called it S Plus. And you had to actually pay money for it. And S Plus became the software of choice for those statisticians who did statistical research. Then 2 guys in New Zealand, can't remember their names, but they do have R as the letter in either the first letter in their first name or the first letter in their last name. I can't remember their names off the top of my head. 2 guys in New Zealand decided to say, hey, we're going to create our own statistical software package that's very similar to S because everyone's familiar with it, but we're going to make it free. And so that's how R came about. It took until about, I would say 15 years ago before it essentially became the standard. It became the language of statistics. So it did take some time, about 2010 or so. There was a landmark story in the New York Times about R that basically kind of changed things. And it became the choice for statisticians and other people who were using statistics. Now, this introduction to R set of notes that I have here is based upon Appendix A of my analysis of categorical data with R book that I've written. So if you would like maybe a more textbook way of doing some of the stuff I'm doing here, you can take a look at my book. The book's available in the library. The first edition's there. The second edition, which just came out last year, I actually haven't checked to see if it's there yet. Okay. Again, R is available for free. And so if we go to the R website, so CRAN stands for Comprehensive R Archive Network. That's what this part of the address is there. You'll see a lot of free softwares out there that have comprehensive space archive networks that are out there for free software. This is the one for R. And here you can have a simple link where you can download the corresponding installations. I primarily use just the Windows one. If you click on it, download base, and go with all the defaults for your installation, you'll be fine. I do use the Linux version on the supercomputers on campus, but I've never actually installed it. Sorry about that. And I do not use Apple computers. And so you download it, you install it, and then you can find the actual icon to open it up. Oh, let's actually get away from that. So the most current version of R is R 4.5.1, but if you use a version that's a couple years old, that should be fine. And this is what R looks like. I'm going to make this a little bit bigger. Now, how many of you use R in this format? Okay. And what format do you typically use? RStudio. Okay. I do not use RStudio. RStudio came out about 15 years ago as well. And it was the first, let's say, graphical user interface to R that made programming easy. There was other interfaces out there, and if you do take a look at my notes, you'll see another one that I use. But it was a lot more accessible, and the key was RStudio had a company that was promoting it. Okay, and so this was always a big fear amongst the R community that some company out there is going to take it over and try to essentially sell it. And we all know you can download a free version of RStudio. And basically all they do is they have a plugin that allows you to access this. But this is what regular old R looks like. And excuse me. And what we have here, we have a little bit of a greater than. We don't have a little bit. We do have a greater than sign there that's in red. This is where you can enter commands. This is what's called the R console window. In default RStudio, for those of you who are familiar with it, in the bottom left-hand corner, you'll see the R console window. And at this console window, you can just do simple math calculations, such as 2 times 3, and then you can use what are called functions in R to do more complex calculations, such as P norm 1.96, where P norm represents probability, normal distribution. And if I hit 1.96, what do you think is going to happen? What's going to calculate? Do the integration in your head. I get 0.975. What that means is the probability that a standard normal random variable is to the left of 1.96 is 0.975. All of you should have seen this. If you have, let's say, often the notation is this, z sub 0.025 is equal to 1.96, or depending upon the actual notation that's being used by a professor or a book, you'll see equations like this. Okay? And so the really cool thing here with R is that it does it automatically for you. There's no reason to have, if you have come across these normal distribution tables or t-distribution tables, you don't need that kind of stuff. We can just simply use what's called a function R to calculate it for us. Okay? Do note that in my notes here, you'll see a few different things that are in like yellow boxes. I put together these notes 4 years ago, and also the videos 4 years ago. And as you might expect, there are small little updates that have occurred, and so I just put those into little yellow boxes. Okay. So oftentimes when you're using R, you like to be able to save the results so you can come back to it later. And so I can do what's called create an object. So I'm going to create an object, for the lack of a better name, called save. And that's going to get the results of 2 plus 2. And notice the syntax that I use here. I use a less than sign and a dash. It's kind of like an arrow. So where you have 2.2, I'm going to point to where the word save is. And so that puts then save into, in R's terminology, an object that saves it there. I can use it for future use for some reason if I wanted to. Now you can also use an equal sign as well. The standard typically is still the less than dash, even though it's one extra little keystroke. But there are some people, a minority, who prefer using an equal sign. You see that more in other languages. Okay. Now, so I told you that I'm saving these results in an object. But where are these actually saved? They're saved in what's called R's workspace. So it's a location that's actually located, if you're using it as like this PC version of R, it's just a simple physical location. It's actually stored in the memory. Excuse me, I was getting different software packages mixed up. It's actually in the actual memory of your computer. That's where it's located. If you want to see a list of all the stuff that's in there, you can just simply type ls parentheses and parentheses, and there you see the word save. ls stands for list. For those of you who have a lot of Linux experience, ls is just a standard command in Linux to list all your files out there. And so the people who first created R and then previously S often use the Linux associated names for this. And so ls, parentheses and parentheses, is an actual function that I'm running. And so, again, if I type save, you see indeed 4 is saved in there. You can also type objects, parentheses and parentheses, and do that as well. Okay? So as I've said here, R has these functions that allow you to do various calculations. You can write your own function to do some of this stuff too. So let's say I want to write a function that calculates the standard deviation of a set of numbers. There's already a function in R called SD that does that, but let's write our own function. So to do that, then, what we can do is I want to create an object. I'm going to call it X for the lack of a better name, that has some data in it. And let's just say it's simply 1, 2, 3, 4, 5. There are more sophisticated ways to have data in R, but this is a place to begin. So to create this simple data form, I can combine together, that's what the C function does, or officially it's called concatenate. I can combine together the numbers 1, 2, 3, 4, 5, put it into an object called X. And something I forgot to also mention here is that whenever I do use this assignment, or this X less than dash, or X equals, this is called this less than dash, or this equals, often referred to as the word gets, G-E-T-S. So X gets the results from using the C function. When I'm combining it together, 1, 2, 3, 4, 5, and there's my data. So now let's write a function that calculates the standard deviation. Well, first, let me just show you that indeed that there is a function called SD out there that calculates the standard deviation. But I want to write my own function, so I'm going to call SD2. SD2 gets, and I need to tell R I have a function. So I say function. And then in parentheses, I say, well, what kind of information would I want to pass into the function? Well, like the data that I want to do the calculations on. How about I just call this numbers? Okay. So I say SD2 gets the results from function, where a particular component of this function is something called numbers. Then I use a left tilde to say, hey, I'm going to now start the body of the function. I hit enter, and what's returned is simply a plus sign, because R says, hey, you need more information. So it's asking for more information. And I'm going to, I guess you could say, cheat a little bit here when how I calculate my standard deviation. Of course, we know standard deviation is the square root of a variance. So I'm going to take advantage of a function called sqrt to calculate the square root. Then I'm going to also use a function called var for variance. And inside there, I'm going to put numbers. And so I'm going to calculate the variance of what's in numbers and also calculate the square root of that. Hit enter. R says, hey, I still need more information. And so I can do a right bracket there to end my function. And so if I type SD2, there you can actually see my function. If I type ls, oops, you can see that SD2 is an actual object that's stored in my workspace. Okay, so if I say SD2, then X, what's going to happen? It's going to actually calculate the standard deviation. Okay. Alternatively, I could also do this. I should say alternatively, I should say also I could do this. I could do SD2 numbers equal X. And this is, I guess, my preferred way of often using functions is because it allows me to specify what X is going to be. It's going to be used as numbers inside of there. Let's do a little bit of a more complicated function here. Let me just type this out quickly. Okay, for those of you who have experience with R, what do you think this cat function is going to do? Excuse me? Categorize? Nope. Thank you for responding, but no, it's not categorize. Nope, that's the C function. So I purposely did this because this is an example of, well, some of you who have a lot of experience with R already, and you're still going to learn something from these Introduction to R notes. So a common programming tool that one uses when one writes a function, especially when you're trying to diagnose problems with the function, is to have results printed off from calculations that are being done in the function so you can see what's going on, where your error is. Okay? And so what that's a little bit more a higher level explanation. Simply what this cat function is going to do is print. So it's going to print x. And I have a slash n there. Has anyone ever seen that before in R? What does it do?
Creates a return.
It basically goes down to the next line. Yeah. And so if I say quote slash n, there's a special name for that, and I cannot remember what it is. I apologize. But I have that within quotes. If I wanted to, I could do this. Print the data, slash n, goes down to the next line, prints x, then it goes down to the next line after that. And then let's actually do square root var numbers and for the next line, so that when I run this, you see it prints the data and it returns the standard deviation. So I could also do this. If I say save gets the results from SD2, notice it still prints. What's inside of save? Well, it's the standard deviation. Now, how did R know, for those of you who are experienced with R, how does R know to put the standard deviation in there rather than print the data 1, 2, 3, 4, 5? Well, yeah, it depends upon what you mean by the output. Maybe I didn't ask the question very well. So, whenever you write an R function, and I would hope that students in their very first class where you use R, you learn this. Whenever you write a function, what's actually returned to the user that you can actually save? It's the information that's in the very last line of the function. That's why save, I call it save. Save only contains 1.58. It doesn't contain print the data 1, 2, 3, 4, 5. In old-fashioned way of programming, you will still see sometimes people do this. What they will do is, for that segment of code there, they will use the function called RET, which stands for return. Return to the user what's in that very last line. Now, in this class, we will not write a whole lot of functions, but we will write some. And so that's why I do this little bit of an introduction to it. Where this will come in most handy, though, is that there are functions that I will write for you. And you need to have a general understanding of what's going on in it, such as what information is going to be returned to you. Well, you look at the very last line of code in that function, and you see what's actually going to be returned to you. There will be a few times in the semester, for example, where we will need to take a function that exists already in R and modify it for our own needs. And so that's why it's good to know some of these basic concepts. But don't be expecting that you're going to be writing function after function after function in this class. That's not the case. We will mostly use functions. It's just important to understand what goes inside of them, what's going on inside of it. Okay. So, how do you get help on, let's say you're stuck doing something or you need help. The code's not running. Well, of course, you can simply do a Google search. But please make sure you're aware that R does have an internal help. There's actually actual manuals inside of R that can help you. Depending upon the situation, my first choice is often to go to the help inside of R. And so you can go up here to help, HTML help. R itself is structured into packages. And all that a package means is a group of functions or maybe data that people have put together, and they've just kind of enclosed it all in one. And if I click on packages here, you're going to see a package called base. this contains some of the most basic functions in R. For that p-norm function that we saw before, that exists in the package called stats. So if I click on stats, p, find p-norm, and click on that, now what you have here is the actual syntax associated with the p-norm function. Okay, so if I say p-norm, if I look at p-norm, notice it says q. Q is called an argument in R's terminology. What is q? Quantiles. So when I executed p-norm 1.96, oops, I'm sorry. Yeah. Let me make sure I'm doing this right. I'm sorry, we use Q-norm, I believe. Let's see. Oh, I guess I did use P-norm. Excuse me. P-norm 1.96. P-norm. Notice I got 0.975 back. What that means is 1.96 is the 0.975 quantile from a standard normal distribution. If I wanted to, I could have put P-norm Q equal 1.96 to be specific. That indeed, I'm talking about that quantile, 1.96. I want to find the corresponding probability associated with it. Probability norm. Now notice here as well, I have some other arguments listed that I did not include. The reason why I didn't include them is because they have default values associated with them. So for example, the mean is 0, the standard deviation is 1. If I wanted to, I could have included those and got exactly the same thing. Typically with the help, at the very bottom, you're going to see some examples that you can copy and paste into the R console and run them. Okay, so we're running out of time here. I do want to mention is that I do not use R exactly like this as I've been just showing you here. Instead, I do use a programming editor called TinR to write my programs. You're welcome to use that. Note that it's only Windows-based. I do have some information in my second set of Introduction to R notes about it. I anticipate that most of you will use RStudio. Despite my comments that I had about it before, you're welcome to use RStudio in this class too. Let's see here. Okay, so what's next in our class? Well, first of all, are there any questions? So what's next in our class? So right after class, I'll have office hours. Do note that there is another class that comes in here. So depending upon how, if you want to catch me, ask some quick questions, depending upon how quick it is, we might have to actually exit the classroom. Please complete that week number 1 quiz on Canvas by 5 p.m. tomorrow. Then on Thursday, we have an optional class. I will give you some help on using R as needed, but I will not present any new material. Then on Tuesday of next week, we will examine the matrix algebra notes. We will continue that on Thursday as well, and then start the data distributions and correlation section. Wednesday of next week, week number 2 quiz is due on Canvas at 5 p.m. Okay, so that's all for today, and I will be seeing you either on Thursday or next Tuesday.